Okay, so today's topic is URDF, and I think last week we just started with URDF and have seen some basic models. Basic models means a link, basically. So this week we are planning to discuss more about URDF, and there is a basic tutorial from ROS Wiki. So we are following the same tutorial. And then tomorrow I'm expecting to discuss the modeling of robot in Fusion 360, and hope we can start something with the simulator. Okay, and after that I can announce the time. I mean additional class hours. It may be like extending the time to 1.5 hour, the session time, or like additional classes only 1 hour but in working days, I mean mostly at night. Okay, so I can announce a time and plan, so let's see how it goes. Okay, so let's start with URDF. I think you may have a you may have taken a look at the URDF topic. Just a sec. So this was the ROS wiki we have used, um, and we have tried something, but we didn't tested these things, but we directly went to an example. Okay, so in order to start, I think we can start with the URDF tutorial that we have discussed last week, and this is actually a good start. Okay, this example from ROS wiki is actually a good start. I'm not directly going to the modeling part using a CAD tool and converting into URDF, because I already explained the reason for that. You have to learn URDF, okay, somehow, because then only you can edit the files that you are modeling in a CAD tool. Okay, so it is essential to learn URDF, and it's actually same with ROS 1 and ROS 2. Okay, so if you check with ROS 2 URDF, you can see the same tutorials. Okay, uh, mostly the URDF doesn't change, it's all same. Okay, so yeah, it's the same thing. You can see the examples. Okay, they are using the same thing. So yeah, so let's start. Okay, let's start with this tutorial, that is URDF building a visual robot model URDF from scratch. Okay, I'm just sharing the link, you can also go through it. Okay, so the first example that we have taken was I mentioned that URDF is an XML based language. So it is having some tags to represent a robot. Okay, so basically in a robot, the main components are joints and links, and also it is having sensors, actuators, and robot is having kinematics. I mean that is the joints and links, and also the dynamics like friction, then damping, inertia, all these things. So all these parameters can be modeled in URDF. Okay, so I mentioned that URDF is actually XML, and there are set of tags associated with it. Okay, tags actually like for example, if you want to mention the properties of the link, then there is a tag called link. Okay, so inside the link you can mention the properties of that link. Okay, so I actually mentioned about the tags of URDF. So these are the existing tags available in URDF. So I think I started with robot and link. Okay, maybe I can show you the progress that we have discussed in the last class. We have written 01 URDF. This was the thing that we have done last week. Okay, um, so uh, maybe I can just start the launch file. So I think I have also explained the launch file. Maybe I can explain it again. So let's start the display.launch file, and I'm putting everything in a package called URDF Tude. So my workspace is Learning ROS workspace. That is the name of the workspace. Inside the SRC, I created a new package which is URDF underscore Tude. Okay, and then inside the Tude, I created a folder called URDF, and then for launching the URDF, we need to write a launch file which is actually keeping in the launch folder. Then so let's start the launch. Okay, so I'm using ROS launch, URDF Tude, and then display.launch. So this launch file is starting set of nodes to visualize a link of the robot. Okay, this is actually a dummy link. You can able to see it's a cylinder. It's a red cylinder, and you are seeing that robot model in RVs. Okay, so one of the use case of RVs is to visualize the robot model. Okay, you are basically visualizing a link now, and I have explained the launch file. This is actually a very important launch file. This actually used to visualize any URDF file. Okay, if you have any URDF file, you can simply visualize using this launch file. So this launch file having some parameters, nodes and all. Okay, you can use the same thing for visualizing any URDF. Got it? So I can start explaining from this launch file, then we will jump into the next tutorial. Okay, let's see. Okay, there is a question from yeah, it's not a question, just a second. Okay, oh okay, so the voice is actually low, seems. Okay, just a second. Okay, so this is a basic launch file to visualize a URI file, and I already mentioned these things, but I can mention it again. So in a launch file, these are the arguments, the command line arguments, right? So similarly, we can pass argument to a launch file using this arg tag. Okay, so if you mention arg name model, meaning model is the argument. Okay, and you can also mention the default value. For example, if you are not giving a command line argument, maybe I can show you how the command line argument works. So this is the launch file. Okay, this is how we are launching the launch file, right? So the command line argument will be like model, and you can, or like there are three command line arguments: model, GUI, and RVs config. So I am putting GUI as false. I'm putting GUI as false as command line argument. So what happening is that the GUI equal to false is actually overriding the default value. If you provide any command line argument, it will be overriding the default value. And see, now we can't able to see any the GUI means it will be showing. Maybe I can show you GUI equal to true. So it will be giving another window. See, this is actually the GUI thing. So in this thing, you can able to see the joins position. Okay, that is actually coming. I will explain. So if you put the GUI as true, then we can see that slider window. If you are putting as false, then you can able to avoid that slider window. Okay, so this is actually command line argument, and these argument, if you are not giving anything, the default value will be taken. And this is an important line of code in this launch file. Basically, if you have a URDF, URDF is actually like a code, okay? So it should be parsed, okay? Or we can say it should be compiled. It should be read out, and then only we can find meaning from it, right? So this is the line that is doing that job, parsing. So here you can see, I don't know, like you have seen this line before. What this does is that actually there is a parameter called robot description. Okay, so the output from this command, okay, this is the command, okay, output from this command is loaded into this parameter. So that is what this line means. So what is the command here? The command is actually running a node called sacro, and sacro space the URDF model. What is the model here? So here, in order to access the command line argument value, we can use like this, like in bracket, start with arg and model. So this will return the value of the command line argument. And in order to find a package, you can use the same thing, like instead of arg you can use a command called find. So this will return the path of the sacro package. Sacro is actually a package. So what happening is that I'm just going to the URDF tut package using ROS CD, and inside that there is a URDF file, right? So what is happening is that this is like sacro and 01 URDF. So this is what happening, guys. Like there is a node called sacro inside a package called sacro. Okay, sacro is actually a package. So if you simply do a ROS CD sacro, you can see this package called sacro. And inside the sacro, there is a node called sacro. This is actually the parser for URDF now. Okay, URDF file is parsing through this node called sacro. And how we can parse it? Just give it as a command line argument. Okay, so this is how we can parse it. So this command, okay, this command is actually the same here. Okay, this is a same command. These two things are the same actually. Okay, so the output of this command is this. Okay, it is actually parsing that XML and output is this, and that output is getting stored in this parameter called robot description. Okay, so this is what happening in this line. Very important, because this is where the robot description is getting parsed and stored. Okay, and then there are two nodes actually. One node is called joint state publisher, and second node is called robot state publisher. So joint state publisher and robot state publisher is already available in ROS. Okay, it's already installed. So joint state publisher, what it does is that it's actually reading the robot description, okay, parameter, and then it is publishing the joint state. Okay, joint state, and the robot state publisher, this node, what it does is that it is actually subscribing from joint state publisher. The joint states it is publishing by robot state publisher, and then it is publishing the TF. So I can show you what is happening from the command line, RQT graph. So I'm starting the display.launch, and I can able to see RVs, and now I'm just checking RQT graph. So we can see the nodes, how the nodes communicating. So this is what happening, guys. So there is a joint state publisher which is actually reading from a parameter called robot description, and then the joint state publisher is publishing the joint states of the robot. Okay, joint states of the robot. So by default it will be 0 0, but yeah, the joint state of the robot, and this joint state is subscribing by a robot state publisher, and that is actually Based on the joint state, it is publishing the TF. Okay, joint state means it will be publishing the state of each joints. Okay, so that can be published using the joint state publisher GUI. I can show you that. Okay, so this is what happening in the display.launch. Okay, so here you can see if we set the GUI equal to true, then it will be loading a node called joint state publisher. But if we if it is true, then it is loading joint state publisher GUI. So in launch file you can implement if else conditions and all. Okay, so if the GUI is true, then it will be launching joint state publisher GUI, which is actually showing that slider window. And if it is false, then it will be simply loading the node without slider. Okay, and this is how we are starting the robot state publisher, and this is how we are starting the RVs with the config. Okay, so these are the things that I think we have discussed that last class. Okay, but I just mentioned it for clarity. So now I can move to the second tutorial of the URDF, which is, so we have done this, and now this is the next example. In this example, they are adding two links. So in between two links there will be a joint, right? So what you have to do is you can simply copy paste this code, okay, from this tutorial, and then simply go to the URDF tut, and then maybe what you can do is either create a new document and save it as where is that? Learn ROS workspace, SASI, URDF tut, URDF 02. Oh, wait, 02.urdf. Okay, so we have saved a URDF called URDF, and you can see the links and joint definition. Okay, so the robot name they are giving us multi shapes. I mean, just a name. Okay, you can change it as test robot or something. I mean, doesn't matter much. And now we can see, instead of one link, you can see two links. Okay, so the link name is base link, and that is a previous previous URDF. Okay, so in the 02 URDF they have added this much. That is the main difference. Okay, so we have base link, and then there is another link called right leg. Okay, right leg, and the shape of the right leg is a box, and the dimension, length, width and breadth is actually given. All the measurements are in meters. So we have two links, and there is a joint definition here that is pretty new to you. So for defining a joint, we have to give a name, and we have to give the type of joints. Okay, so ROS URDF will support a set of joints. So in order to identify the supported joints in URDF, just take the joint tag, and then you can able to see the type of joint supported by URDF. So the type, one type is fixed. Fixed means it will not move. Okay, it's actually fixed joint, so it can't move. Okay, all the degrees of freedom are locked. And then the next joint is revolute. Okay, revolute means like it can rotate along the axis with a limited range. Okay, there is a limit in which it can rotate. So maybe one joint can rotate between 20 degree to 60 degree. So all the limits are in radians. In ROS we are representing angles in radians actually. Okay, not in degrees. So revolute is that kind of joint. And continuous joint, you can say it's a wheel joint. Wheel joint is continuously rotating, right? There is no upper limit and lower limit, so that is continuous joint. And there is prismatic joint, it's like a sliding joint, right? So the it will be sliding. It is like 3D printer joint, like you have seen a 3D printer, right? So the 3D printer is like sliding, right? So that kind of joints is called prismatic. And then there is a floating joint and planar joint, but mostly like we will be using these much joints. Okay, so yes, so uh, here we are using the fixed joint, and inside the joint definition we have to mention what is a parent link and what is the child link. Okay, so like just a sec. Okay, URDF majors. Yeah, so in the URDF, if you check, oh, this is actually, oh, it's a good one. Yeah, so in order to define a joint, there should be a parent link and there should be a child link, right? So parent is actually in the bottom, and child is actually the connecting. So joint is actually connecting the parent and child. Okay, and the joint can rotate in 3 axes, not only 6 axes, but each joints may be limited. Okay, there will be limitation. So some joints may be rotating, some revolute joint can rotate only in 1 axis. Some joints can rotate in maybe 2 axis, or something like that. So there is a parent and child frame, I mean child link, and then it is connecting through a joint. So that is what mentioning here, which is a parent link and which is a child link. So here we have put the base link as the parent link and then child link as the right leg. So now we are saving it, okay, as 0 to URDF. Okay, now we have to display it, right? We have to display it. So in order to display, it's actually very easy. We can use the display.launch. Okay, display.launch, same launch file with different model. So just use ROS launch and then URDF tut, then URDF tut and the display.launch, and then model, change the command line argument. The default model is 01.urdf. We are actually changing from changing to 0.urdf. So make sure you are executing from the URDF folder itself. Okay, otherwise you have to mention the entire path of the file. Okay, so if I'm doing like this, let's see what will happen. So I think it is actually taken, and here is the URDF. Here you can see the old cylinder is there. Just a sec. The old cylinder is here, and in between there is a box. Okay, the box is actually crossing the cylinder. Okay, so and if you put the TF on, okay, you can able to see, just a sec. So the TF is actually publishing on the joints. Okay, so here you can able to see the TF is on the center. So here in the joint definition, we are not mentioning any joint origins or anything. So by default, the joint position origin will be at 0, 0. Okay, so that's why we are seeing the joint at 0, 0, because see, it's actually at the origin, the grid center. You can see the joint is actually at the origin. Okay, so this is the TF, and you can able to see the frame. Yeah, so there is base link and then right leg. There are 2 frames, but basically the frame actually I mean the origin of the two frames are in the center, or I mean the origin of the the origin is in 0 0. Okay, so yeah, just a second. Yeah, so actually uh, the frame actually showing with the link, but the join it actually publishing, or it is actually visualizing in the joint origin. Maybe we can discuss that in the upcoming URDF definition, so you will get a clarity. So here there is there are two links, base link and right link, which is connected through a joint. Okay, so this is a simple joint definition using URDF. Okay, and you can able to visualize the TF. You can yeah, if you check the TF static, let's see. Yeah, the TF static is basically publishing 0 0 0. Okay, because the joint is in the origin, there is no transform between I mean, yeah, it's simply at the origin, both the links are in the origin. Okay, the joints is in the origin. Now we are switching to the next section of URDF. So we have seen this. Now just we are going to the third section, which is origins. So here we are adding the origins of the joints. Okay, so the origins are there for links and joints. Okay, maybe you can actually see that. So you can actually shift the link, and we can also shift the joint origin. So I'm just copy pasting this code into new file and saving it as 03. Just a second. So yeah, 03.urdf. So what is the difference between this and this? The main difference is that these links and joints doesn't have the origin, but in this URDF you can able to see there is an origin for the right leg, I mean the link, and there is an origin for the joint. Okay, so we can position where is the joint and where is the link. Okay, so that is what the origin is for. Okay, so for origin there is a XYZ distance and also the roll pitio. Okay, XYZ is in meters and roll pitio is in radians. So now we can simply visualize. Currently, like for joints, I think they didn't give the RPi value, but we can also set the RPi value for the joints. Okay, so now we can simply visualize. Just a sec. Instead of 02, we can give 03, and let's see the change. Okay, so now the change is actually very visible. From the origin, when we shift the when we shift the link, that is right leg, you can able to see the right leg actually shifted to here. And where is the joint? Where is actually the joint? Joint is here. Okay, so you can see the joint position XYZ is 0 minus 0.22 0.25. Okay, so like if you check, the red color is actually pointing to X direction, green is actually Y, and C pointing upwards. Okay, so if you check the joined origin, you can see joined origin is basically just a second. Yeah okay. Yes, so what is actually different here? The joined is X is actually doesn't change. X axis is not moved, it's zero actually, right? Y axis it's actually negative. So maybe I can give an alpha value to 0.5 so you get a clarity here. The center is actually the base link. Okay, so from the center, the right leg joint is actually I mean it's actually put it in the negative direction, right? So you can see it's minus 0.22, the y value, x is 0, and z value is 0.25, positive 25. So that's why this link is up. Okay, imagine if we are changing the c value to point maybe 1. Okay, 1. Now we can see what will happen. So if you just put the joint values to 1, then the joint will be moved to 1 unit or 1 meter. Okay, 1 meter. So the link will also shift. So in order to shift the link position, we can change the link origin. Okay, so this is how we are editing the URDF. For example, if you are changing the link value to 0, and if you visualizing it, we can see it's actually like moved away, right? See, it's actually moved up. Okay, so if you want to like move down, you can simply put -1 or something, and then if you check it, see, it's actually moved along with the cylinder, but the joint is still here. Okay, so what I am suggesting is, like, first change the joint position. The joint position is the most important one. Okay, based on the joint position, we ROS is computing the TF. Okay, so joint origin is the important one. The link is just for visualization. Okay, but link is also having importance while doing the simulation. But what I'm trying to say is, first fix the joint and then correct the link origin, adjust the link origin. So this is what happening. So from this example, this is a real example. You can able to see we have shift the model to right side. Okay, like a leg. Okay, it's corresponding to a right leg, and here is the joint between the base link and the right leg. Okay, this is the connection. Okay, so this is the connection between base link and right leg. Okay, so now we can move to the next section, that is material girl. Oh, yeah, I mean, like I mentioned that in robot link we can add the visual elements. Like currently we have seen the color as red, right? We can actually change it. we can actually change a color, texture and everything. So this example simply showing two legs, the robot two legs, and with the visualization with the material property of the URDF. Okay, simply copy pasting and then saving it as 04.urdf. Okay, so in this example the difference is that here I have the base link, then right leg, and then joined to the right leg, and then I have also put a left leg, okay, and then the joints to the left leg. Okay, in addition to that we have changed the color of the link. Okay, here we have used an additional tag called material, which is under the visual tag. Okay, so here is what we define the material. Here we define a material called blue, and here we can give the color of that, I mean the color that is corresponding to the blue. So if I'm calling material name blue, it will give this color to that link, and if it is white, it is giving this color, something like that. So let me visualize 04, and after that I can explain. So yeah, so this is how it looks like. So this example actually building R2D2 robot. So R2D2 will be look like this. I mean, it is having two legs. So you can see here is the right leg joint that we already seen, and this is the left leg. So you can see the joint value here. The y-axis, you can easily see for the right leg y value was negative, but for left leg the y value is positive, and x value for both joint is 0 and c value is the same. So that is the difference that you can see. For left leg y is positive, but for right y is actually negative. Okay, that is the only thing. Okay, and we have seen the material. Okay, so that is what this example is about. And now I'm going to the next session, which is finishing the model. Okay, so I think in this example they have added almost all the stuff. Okay, this is a big one, so I'm simply copy pasting. Maybe there is a source code as well. I'm simply copy pasting and then creating a new file. Yeah, saving learning, where is that? Okay, learning workspace, URDF tut, URDF 05.urdf. Okay, here they have added a lot of stuff. Okay, but we can see. Okay, we can see first. So 05, what is the model? Let's see. Yes, so this is the model now. Okay, you can able to see the model. This is the R2D2 robot, and they have added wheels. Okay, and they have added head. Okay, there are a lot of joints. The frame that you are seeing, right, all these are joints. So we have left leg, right leg, then there is a box, there is a gripper, there is a wheel joint, there are 4 wheels, then yeah, there is a gripper. Let's see, show names. So this is the TF that is publishing in each joints. Okay, so which is publishing this TF? The robot state publisher. Okay, and maybe I can also show you the RQT graph, not RQT graph, TF tree. This is the TF tree. Okay, maybe I can start with the 02 TF tree so you will get an idea. So let me start the 02 URDF and then visualize the TF tree. So if you check the 02.urdf, you can see the TF tree like this. And if you move to 03, then we have add, I think we have add the left leg as well. Let's see. No, we didn't add left leg. So the TF will be the same. So in the 04, if you start, yeah, it is having left leg, and if you simply visualize the TF tree, you can able to see the base link, left leg and right leg. Okay, now for the fifth one, they have added all the joints. Okay, all the joint, but there is a thing, all the joints actually for the fifth one it is fixed. Okay, so that is only the thing. So here you can see all the joints are added, and then we can check the RQT. So you can see the base link is here, and then left leg is here. In the left leg, they actually put a base. You can visually see it. So here is the left leg. On the bottom, they actually put another link called left base. Okay, this is the left base, and then on the left base, there are left back wheel and left front wheel. Okay, and in the right side, it's the same. So you can see the TF. Like on the right leg, there is a right base, right back wheel and right front wheel. Okay, and then there is a gripper pole. Okay, gripper pole is on the front. So from the base link, there is a gripper pole which is actually a prismatic joint, and from the gripper pole there is a left gripper and right gripper, and there is another tip here. Okay, so I think yeah, that there is a tip joint, and other than that there is a head. From the base link there is a head. So if you visualize the TF, you can see everything is going from the base link. Base link is the root one. Let me just all are enabled. Okay, so I can easily show you like all transform. So this is the base link. This is the transform of base link from the, I mean, transform from base link to head. Okay, so like that you can easily see the transform. Okay, so this is from head to box. Okay, so like that. So in the fifth example, we can see they actually put all the joints, but all the joints for the fifth version, actually everything is fixed. Okay, everything is fixed. So this example is just for like showing the entire model, but nothing will move. Okay, no joints will move. But in the actual scenario, everything is not fixed. Something are continuous, something some joints are revolute, some joints are prismatic. Okay, so in the next example, that is what, just a second. Yeah, this is what we have seen, and now we have to make it move. Okay, so that's what this example is about. Let me see whether there is any source code. Okay, Yeah, I think, or I can check for the URDF tutorial. URDF tutorial ROS. I can take it from the repository. Yeah, I think flexible. Yeah, this is the next version. Okay, so I'm simply copying it and then I'm saving it. 06.urdf. So now let's visualize it. We can see, let's see the difference. Okay, I think it's the same thing that we have copied before. We need, I think, physics. The joins should be, oh, all the joints. Okay, this one thing is correct. Okay. Oh, I visualize actually 0.5 itself. No problem. So here the things got changed. Okay. So for the joint state publisher, you can able to see there is a slider on the left side, left or right side. Okay. And then if you move the slider, okay, not here, maybe I can just show you the gripper extension. See, if you just move the gripper extension, basically the gripper is actually moving, and if you move the left gripper joint, left gripper is opening, right gripper joint, right gripper is opening, and if you change the slider, the head is actually rotating. Okay, so basically what we are doing is, from the sliders, what we are doing is we are actually publishing the joint states. Okay, using this we are publishing the joint states. So the joint states are subscribing by the robot pose, so the robot state publisher, and it is publishing the TF. Okay, so if you change any joint, you can see it is rotating. Okay, the TF is actually changing. Okay, if you check all these things, the prismatic joint, this is actually a prismatic joint. This is how the prismatic joint works. And this, the gripper, no, gripper is actually a revolute joint. It will only move in a certain angle. Okay, gripper joint. And then a right wheel joint, which is a continuous joint. Then head swivel, it's again a revolute joint. Okay, revolute joint. Okay, there is an option called randomize, so it will be publishing random values to these joints, and if you center it, it will be in the default position. Okay, so this is the final version of the URDF. Okay, so we can see the differences. Like, we can now see what is in the URDF. It's actually, like, if you watch closely, there is no complexity in the URDF. It's basically the relationship between links and joins. Okay, so that is a primary thing. So when the number of links and joins increase, then the length of the URDF obviously increase. Okay, and inside the link and inside the joins, we can actually define a lot of stuff. Okay, so you can see one by one, like the base link, right leg, these are links, right base. So currently we have seen the base link, joins between base link and right leg, Now there is a joint between right leg and right base. Hope you have seen the base. This is the base. Okay. So then from the base there are two wheels. So you can see the joints of the wheels, that is from the base to right front wheel. Okay, and you have to set the joints, joint origin and all, and the wheels are continuous, and the right base joint is fixed. Okay, and if you just scroll down, you can find the wheels, all the wheels are continuous, and the gripper extension, it is actually prismatic. Okay, and there is some limits. Okay, upper limit and lower limit. Then gripper joints are revolute. Okay, the gripper joints are revolute, and yeah, right gripper joint revolute, and yeah. So when you just scroll down, I mean, you can see it's actually a big one, having 417 lines of code. Okay, and but the fundamental thing is it's actually having links and joints. So two links and one joint. That is actually the combination. There will be a parent link and there will be a child link, and there is a joint between them. Okay, and if you watch closely, you can see. So the URDF is having some primitive shapes. Primitive shape means some shapes that is actually very common, like sphere, then cube or rectangular box, cylinder. Okay, so these things are like primitive shapes. So here we are using a lot of primitive shape. We are using cylinder, box, sphere. Okay, but for the gripper, you can see it's not a primitive shape model, right? If you check it, it's not a primitive shape. It's actually a mesh. Okay, it's actually a mesh. So how can we put a mesh for the link? So that is what I already mentioned it. So this is how we can represent a link with a mesh. Okay, so in the geometry, in the link tag, we can actually put the mesh link. Okay, mesh link mean mesh path. Okay, this indicate that there inside the URDF tutorial package there is a mesh file, mesh folder, and the mesh file is the Lfinger DAE. Okay, but actually we didn't copy any mesh or something, right? But actually the URDF tutorial package is already there when you install ROS. Okay, so that's why it is having the meshes folder. Okay, so what we have practiced, everything is available in the package. Okay, it's already installed. Okay, we have just gone through this tutorial package, that's it. Okay, so if you check the URDF, you can see the URDF that we have discussed, it's already available here. Okay, so and if you go to the folder of meshes, I can easily show you the meshes using meshlab lfinger.da. So there is a tool called meshlab. Okay, you can easily install meshlab using command line. You can simply install like using this command sudo apt install meshlab. Okay, so we may have to use meshlab often while working with the robot model. The meshlab is actually a CAD model viewer and some kind of modifier. So this is actually the CAD model of the one gripper. Okay, left side or right side gripper, left side gripper. Okay, so using meshlab you can able to do the visualization and also some filtering and all. Okay, So mesh lab will be useful. That mesh is actually showing here with texture. Okay. Yes. So this is how we can create the URDF manually. Okay, we have been discussing about the manual URDF creation. So once we are in track, I think we can create our own URDF. It's not a big deal, but it will take time to I mean properly learn this stuff. Okay, and other than that, let me check if there is any other things. Um, yeah. So if you just go through it, you can find there are some other tags in the join like axis. Okay, so axis means the join will be rotating on here. It will be rotating on C axis. It's actually a revolute joint, and it should rotate on the C axis. So these axis of rotation we can set, and then let me see if there is any other things. Yeah, so in the link tag we can actually mention the dynamic properties of the link like inertia. Okay, so in the inertia inertial tag, okay, this is another tag that is coming in the link. So we can actually mention inertia and the collision. Okay, so the collision means we have to put a collision boundary for each links. That is actually useful for detecting the collision in simulation, mainly in simulation actually. Okay, and inertial tags actually representing the mass of link. If a link is having 10 kg, you can put mass as 10 kg, and this is the inertial metrics. This is actually getting from the 3D modeling tool, but we can compute some other way. Okay, so these things are the dynamic parameter, not the collision but the inertia. Okay, and so I think this example is having most of the stuff that we require. Okay, yes, I think we can just conclude for today, and for tomorrow I will explain about Sacro, and I will show you how to design with Fusion 360. I have a limited understanding about it, but let's try. Okay, so now it's a time for Q&A. So let's talk. I mean, if you have any difficulty in understanding URDF, let me know. Like, it's actually will take some time to learn for sure, and it's boring as well. So let me know if you have any question in this session. So regarding the tags or idea, if you need any further clarification, let me know. Time for questions. Yes, yes.
Hello, sir. If we copy this URDF example to a text file and adding in a package, and just ROS run this URDF, is it will be working or showing
So
error?
the question is, you are copying this URDF into a text file, right? And then,
Yes, and saving it as a .urdf file in
okay,
a
so
package.
like you are putting that inside a URDF package. Okay, I mean a ROS package like this, right? You are saving it, right? And then you
Yes.
are running the launch file, right? Like the URDF is actually not a program. I mean, it's not like Python or C++. It actually need a parser. Okay, so in order to work with the URDF, you need to launch this launch file, or you need to run these nodes. Okay, then it will work. So this URDF will work with in any system which is having ROS Noetic full installation. Okay, you have to run this launch file. That is only the thing. Okay.
Okay, so we have to add
Yeah,
this
yeah.
launch file
Launch
also,
file
right,
is
sir?
important because in order to parse the
Okay.
URDF, we need to start the launch file. Yes, it's not like Python or C++ like running a node. It's not a node actually. It's actually a file which require a parser, and that is actually a node. So that node is actually running along with the URDF. Any more question regarding the joins and links? You can simply go through the URDF and visualize it, do some modification, and again, so just experiment, okay, with this tutorial. Okay, this is having all the information, but this is how we can start working. Okay, I will update this repository that we have created in the source code folder. Okay, so tomorrow we will be starting working on the sacro, so which is actually a modular way of writing URDF, so that you can actually implement equations, then you can actually add if loop or something like that, like a programming language we can add things. Tomorrow we will be starting with sacro, and then we will be going with the fusion 360 or something. Okay, so thanks for attending. So see you tomorrow, guys, same time. Maybe there will be some changes in time, but I will let you know. Okay then, bye.